Determine whether or not the points A, 2, 5, B, -1, -1, and C, -4, -8, are collinear. To be collinear, points would have to line up on the exact same line. For this question, there are two methods we can use. The first method is to use slopes. Recall the formula for slope: m equals y2 minus y1, the change in y coordinates, divided by x2 minus x1, the change in x coordinates. If the slopes of all line segments AB, AC, and BC are equal, then A, B, and C must lie on the same line. If the slopes are not equal, then these points cannot lie on the same line. Here we simply calculate all of the slopes and compare. Let's first plot the points. Point A at 2, 5, B at -1, -1, and C at -4, -8. Note that at first glance it appears as though these points do fall in a straight line. Let's first consider line segment AB. Figuring out the slope of line segment AB, y2 minus y1 is -1 minus 5, divided by x2 minus x1, -1 minus 2. This results in -6 over -3, which is equal to 2 for the slope of line segment AB. Moving on to line segment BC. Again, figuring out the slope, the change in y coordinates, -8 minus -1, divided by the change in x coordinates, -4 minus -1. This gives a result of -7 over -3, or 7 over 3. Note that 2 is not equal to 7 over 3, therefore these points cannot be collinear. Note we could have also figured out the slope of line segment AC, and it would have also been different from both of AB and BC, but we didn't need to take this step. Method 2. For this case, we're going to use distances. Using the distance formula, d is equal to the difference in x coordinates squared plus the difference in y coordinates squared, all square rooted. If the distance between AB and BC is equal to the distance between A and C, then the points A, B, and C must be collinear. If these distances do not equal, then the points are not collinear. First of all, let's find the distance AB. We use the distance formula. We take the x coordinates and square them, and then we add the difference between the y coordinates and square them. This gives a result of the square root of 45, or 6.7082, rounded to 4 decimal places. Next, for BC. Again, we use the distance formula, the difference in the x coordinates, -4 minus -1, all squared, plus the difference in the y coordinates, -8 minus -1, all squared. This gives us the square root of 58, 7.6158 to 4 decimal places. Finally, the long line segment AC. Again, the distance formula, the change in x coordinates, -4 minus 2 squared, plus the change in y coordinates, -8 minus 5 squared. This gives us the square root of 205, which is equal to 14.3178. Taking a look at the distance between AB and BC, if we add those together, we get 14.3240, Note that this is close to 14.3178, which is the length of AC, however, not exactly the same. Therefore, we can say that these points are not collinear.